Okay, moving on to example number 2. In this example, we are asked to find the force. So we have two forces given and we have one magnitude given. And there's another force here, and we're asked if we have a magnitude of, if we have the resultant of 500 newtons, how much, what's the magnitude and what's the direction of this single force here? So in our previous examples, we had to find the resultant. Well, in this example, the resultant is given, and we have to find this one single force that makes up this resultant of 500 newtons. So the first thing I did here was I drew all these forces. I drew a single force here. So we'll just fill this information in, which is 30 degrees, and it is 75. This one is 100, and this is 60 degrees, because adding up 30 by 30. This is 500 straight up, and this is obviously this is the resultant. So this force is the resultant force. This is another force, and we have to find the theta, and we have to find the magnitude. So the first thing I would do is let's find the components of each of these forces. Let's find the components of the forces that we have at least. So then this one would be x is equal to 75 cos 30 degrees, which equals, remember this direction is going this way, so it is negative 65. Y therefore is equal to 75 sine 30 degrees, and it's going up, so it's going to be positive of 37.5. I'll just change colors here. So let's find this, the x, which is equal to 100 cos 60 degrees, which equals minus 50, because remember it's going in the negative direction. Y is equal to 100 sine 60 degrees, which equals 86.6, and it's obviously going up, so it's going in a positive direction. In this one, x, well, there is no value for x. X is on the 0, so x is equal to 0. And y, well, y is 500. For this one, we don't know anything. We don't know. So then let's add up all the x forces, and we're going to equal it to the resultant. So we're going to say that fx is equal to minus 65 from the first one, minus 50. And for this one, well, we don't know, so we're going to say plus x equals the value of the component of the resultant. The x component of the resultant is 0, so it's going to equal to 0. So we're going to solve for x. X is equal to 115. So the component x for this is 115 of this unknown force that we're trying to find. So let's do the y forces here. If y is equal to, we'll take the first one, which is 37.5, plus the second one was 86.6, and that's coming from here, plus, well, this is unknown, right? We don't know. Plus y is equal to, well, this one won't be 0. This one, the resultant, the y component of this is 500, right? So we're going to say is equal to 500. Therefore, if we substitute for y, y is equal to 375.9. And that's this force right here. So we just found the components of this unknown force. Well, we found the x and we found the y. The y is 375.9. So we still don't know the magnitude of it. We found the components, we still don't know the magnitude. So we would apply Pythagorean theorem. Remember, if we just do this, it's a right angle triangle. So we just apply Pythagoras theorem, which is s squared, because I'm going to call this x because that's the one we're trying to find out. X squared is equal to 115 squared plus 375.9 squared. Therefore, s is equal to 393.1 newtons. Just gonna go down a little bit, give me more space. Well, now we know that this is 393.1 newtons. We still don't know, well, we know the magnitude, we still don't know the direction. We know it's in the first quadrant, but just how many degrees is it? For that, we're gonna apply, remember SOHCAHTOA? So we're gonna apply tan theta is equal to the opposite over adjacent, opposite being 375.9, adjacent being 115 to the tan negative 1, and then theta 1 is equal to 73 degrees. So therefore, sorry, not the resultant, this is actually the S force. Therefore, the S force is equal to 393.1 newtons at 73 degrees this direction.